Good morning. Thank you for joining us today. I'm Sean Smith from Wessex Water. My previous role in Wessex was a senior mechanical engineer, and I've moved into a DSEAR Compliance Manager role this year. 25 years experience, mechanical experience at Wessex Water, doing a variety of roles, but mainly now my job is to look after DSEAR compliance and process safety. This PowerPoint is a representation of the journey we've been on at Wessex Water since the incident. 3rd December 2020, it was a day that changed the water industry. 11:05 a.m. on the 3rd December 2020, a tragic event occurred at our Avonmouth site. It was covered by the worldwide media, Sky News and all the media channels. A tragic incident which resulted in 4 fatalities, 4 people that had worked for a long time at Wessex Water, and a 16-year-old apprentice. The incidents changed the industry positively. It's had an impact on everybody within the water industry and the wider process safety industry. It opened up an opportunity for us to review our approach to safety and of DSEAR and how we could use process safety as an enabling tool to help us comply with DSEAR. The initial investigation by the HSE gave us an opportunity to review our position, and it was really the starting point of our journey in understanding our business maturity, where we were in regards to DSEAR compliance, and the fact that we hadn't really understood the benefits of integrating process safety into what we do as an organisation. We had a job to do while the investigation was going on. We had lots of questions and we had lots of feedback from the HSE inspectors that were on site looking into the incident. They were very supportive and the feedback we got was very constructive from them. It became quite clear in the early days post-incident that we needed to carry out a detailed gap analysis of our current approach to DSEAR. We've been doing that and it's still ongoing. It's a piece of work that's going to span over years, and we're getting right into understanding what we need to do, what changes we needed to make, our levels of compliance against the regulation. There's a whole lot of work about competency that I'll cover later. The incident happened, reviewing some of the aspects of how we managed the process at Avonmouth, made it clear that we needed to integrate process safety. For us at Wessex Water, it was a new concept, a new discipline, a new approach that we have been learning. There's a lot of people been training with process safety in mind. We've done a lot with IChemE, and we've been developing people's skills to understand the importance of process safety and how it applies to a high hazard facility. Understanding the regulations in detail. So DSEAR is a complex regulation. It's supported by L138, which is the ACOP. It makes it easier to understand. It's been a journey to understand in detail what we need to do as a duty holder to ensure that we're complying with the regulation. And again, we've done a lot of training around DSEAR. We've looked at staff competency and we've set up both internal and external training to ensure that we get to a level of competency that we're comfortable that we can comply with the regulations. We reviewed our procedures and working arrangements. And again, when you do a deep delve review of some of your procedures and your working arrangements, again, it became clear that we had a significant gap we needed to fill. We needed to rationalize some of the documentation and ensure that all the paperwork that you need to make something safe to do as a task was in place and appropriate for the hazard that you are trying to manage. Operational competency is essential to support this function. So we did a deep delve review of competency that led on to further work and wider industry work. And again, this is leading to Wessex developing an internal competency management system, a way of assessing people's competency against roles and their responsibility for doing the tasks that they're engaged to do. We're reviewing an action and the feedback from the HSE, and that's been ongoing over the last 4 and a bit years. Avonmouth has become a lower tier coma site, and we're dealing with the CA on a regular basis now as they come in and do interventions. Prioritising tasks and resourcing. So another area where we understand now that we've got safety critical equipment, we understand that these have specific tasks and those tasks have to be identified. We've been developing SOPs, standard operating procedures, or safety operating procedures, they can be referred to as well, for safety critical equipment, ensuring that that's done, it's resourced appropriately, and it's done in a timely manner. We've put together a detailed inspection program, and we've got the logistics in the background, making sure that safety critical equipment has got the essential spares, especially with long lead time equipment, that we can support a failure of any safety critical equipment in our process system. You had to continue operating Avonmouth. The operability of the site, given the fact we had a huge area of the site that was under HSE control, we had to continue managing sludge throughput, and that again had another impact on how we managed DSEAR. So we had a huge area that was demarked for centrifuges and moving the sludge from post-digestion through some centrifuges. Another area that we found we had some gaps was process, control and information. So when we looked at our gas system as a whole system, the amount of information that we need from that system to understand how to manage a process appropriately, again, was a piece of work that's still ongoing, but there's far more instrumentation and equipment in the gas train than we originally believed we needed. Understanding some of the hierarchical behaviours within the organisation and how they influence others and our corporate approach to safety. So again, this is underpinning process safety leadership within our organisation. This is a top-down change, a top-down influence in culture to drive a new process safety embedded safety culture within our organisation. And this is right across everybody within Wessex Water, to be empowered to understand how they can go about their daily work and enable them and empower them to stop work if they don't believe it's safe. So we've had a real cultural change right from operations level to board level in the acceptance that if we need to stop work, we simply do. We raise it with a senior member of staff, and then we review what's going on to make sure that all work is done as safely as it can be done to ALARP. We've understood that leadership qualities have to engage and empower staff. It's got to be a defined level of leadership from the senior leadership team. Safety has to be one of the first things we discuss, and safety should be always one of the things that's discussed when we go out and meet the operators and the managers on site. Like all businesses, we've got a business drive to balance cost and compliance along with driving a really good and robust safety culture. So whilst we have to manage our budgets, we have to also ensure that we're resourcing and funding a drive towards ensuring that all of our sites are safe, and we're embedding this safety culture within Wessex Water. Another piece of work we did off the back of the review was looking at resource levels and defining roles and responsibilities, making sure that we're not overloading staff with tasks, giving them enough time to balance our workload, and we're making sure that where we've got safety critical, process critical tasks going on sites, that we've got enough resources to manage all of the permitting and paperwork to enable those jobs to go ahead safely. We're promoting a first class safety approach. So we've adopted the Plan, Do, Check, Act approach to what we do. We've got a system within Wessex called Take 5 to Check 5, and it's these checking that you've got all you need before you start the task. So you've got the right resources, you've got the right level of competency, you've got the right tools, you've got any associated equipment you need to do that task safely. A part of the competency management system that we're embedded into our business is to review every single role within the organisation, understand what responsibilities are required from that role, and ensure that we can match a level of competency within our training matrix to the output of each role, clearly defining roles and responsibilities right across the business. We've done a fundamental review of operational requirements, and we're mapping these to the roles, and we're looking at resource availability. We're producing some business cases where we've identified an area where we need additional resources to enable us to carry out the task safely. The gap analysis of the fundamental causes, highlight areas for improvement from the HSE, which is what we've been talking about, competency, resourcing, having clear and concise guidance, policies and procedures. We've had for a long time within Wessex a mentoring and leadership team, and we've made sure that that leadership team and engagement is right across all of our business areas now. So we've made a big step in improving the mentoring, the leadership, and some of the coaching that we do with our staff. All of the areas we identified for improvement out of the Avonmouth investigation been rolled out to all the other sites. So we're trying to embed a safety culture right across the organisation, understanding that we are operating multiple high hazard facilities in waste and supply, and the safety message is going out as a consistent one. We want our operational procedures, we want clarity of them, we want consistency of the approach, and we want to implement a really good process safety culture right across the organisation. We've done a lot of work around our ATEX equipment. So we've set up a database that we're integrating with our Dynamics work management system, and that's a list of our ATEX register, all of the ATEX equipment, all of the safety critical equipment, and within Dynamics, if it's safety critical, it's got a flag associated with it. So the maintenance for those assets have to be done when they're scheduled, and there's no real workaround. We need to make sure that we plan what we're doing and we keep on top of our assets, especially the ATEX and critical safety ones. We looked at our general site information, our P&ID, our process flow diagrams and information, looking at URSs as the whole system rather than done in isolation. So when we do a scheme, we make a change to the site. We didn't necessarily look at the whole system at the time. So one of the things that we're doing now is whenever we've got to make a change or we're adding a bit to a site, we review the whole process system, and then any URS changes that we need to make are site-wide to ensure that the change is suitable and sufficient for what we're doing. We've also implemented a robust management of change system, which we didn't have prior to the event, and that's based around any process changes whatsoever have to go through an approval process with a process engineer. It's got a sign off, and we can't make the changes until everyone's agreed what the change is, the impact and consequence of that change. Feedback from the HSE recommended we had a bottom-up review, influence and change within the organisation, and that's empowered people to really be involved with our processes, our procedures, understand why we need to change, rather than them feeling we were just putting an extra load of paperwork on them that was unnecessary. So it's been really successful having this bottom-up review of what we need to do and operator worker engagement along all of the changes, and there are many changes we've been making to our documents and our procedures throughout this process. Site security is another area where we've really focused on. So we've got dedicated security on our major hazard sites now. We've got a gatehouse. Nobody can get on site without them going through our security. There's a lot of work people need to do before they come to a high hazard facility now that we didn't have to do before. Everyone's getting a specific induction for whatever the site hazards are, site awareness, and that's being communicated across all business areas. We're ensuring that our PPMs, personal gas monitors, are all bump tested and calibrated, and they're used now as a mandatory requirement on the high hazard facilities. Our contractor and visitor access to sites is very well controlled. So we've got a new system, electronic system. You have to go and log in. You have to go through an induction to get your visitor or contractor pass. We've got site whereabouts plans up around the site. So it identifies where the zoning is, where the emergency exit routes are, and it references our emergency plans. When we leave site, anybody who's come logged into site is given a PGM, and they may have some PPE issued to them. That's all logged in and out and returned at the end of the site visit. So a deep delve into competencies enabled us to understand what the basic competence requirements are for working on high hazard facilities, especially in gas production. We've got on 5 of our gas production sites. That involved a lot of work with our training suppliers. So we've done some work with Compex and we've shared that work, and we've got a really good working group across the industry now in regards to understanding what the basic needs of training is, external training to allow our staff to become competent to do their electrical, mechanical, ATEX work, and right down to operators having complex training to be on a high hazard facility. There's a focus on DSEAR and process safety. We've got a lot of other regulations that need considering, especially in design phase. In AMP8, it's a huge investment program, and safety starts at outline design. So we're looking at process safety hazard studies 1 to 6, implementing the hazard HAZOP LOPA studies, and engaging engineering to use that platform to understand what the outline designs need to look like. So we're starting on the right foot when it comes to outline design, ensuring that the end product that we're going to hand to operations is safe and suitable. It's designed well, it's got good access, it's easily maintained, and we look at all the other regulatory guidance as well as the DSEAR, so PURA, LORA, COSH, PSSR, they're all integrated in this outline design process now. There's been a step change in understanding within the organisation that we are managing high risk, high hazard sites, and moving from being 100% occupational safety. So we had a really good approach with occupational safety, and now we've embedded process safety into our occupational safety. So we've got still all the high frequency, low consequence events that we manage in our reporting system, and then we're focusing on the infrequent high consequence events that sit within the process safety remit. As I said earlier, we're really focusing on management of change, so we've got that embedded now into our business. We're moving from just it being a process management of change to a more organisational management of change. So we want to get to a point where any change in the business is reviewed to ensure that the consequence or likely consequences are managed and understood. And this includes organisational management of change. The water industry restructures frequently, understanding what the roles are in the existing structure and what the roles are going to be in the new structure are really important, and identifying safety critical roles to ensure that if there is a change, that these safety critical roles are understood and ensure there's no gaps post restructure. Cultural awareness and understanding of our position. So we've communicated out to the wider business that we are on a journey. The whole water industry is on a similar journey, and it's reviewing our position. It's planning and mapping out what we need to do in a timeline and how we're going to do it and how we're going to implement that change. Understanding our portfolio of assets, our electrical, mechanical assets, and our ATEX register. It's been a huge piece of work. We've been supported by external contractors to deliver that program of work, and we're now in a position where we're inspecting our equipment, we're doing the remedial works, and we understand what the asset portfolio looks like. And the enormity of the task when we started it was quite overwhelming, but it's taken a while, and we're now in a more comfortable position in understanding what the assets are, what the inspection regime needs to be, and how often we need to ensure that we've got them inspected and the remediation work is done in a timely manner. We've adopted our own time to repair matrix for ATEX equipment following the guidance from Compex. So we've got C1, C2, C3, and internally each site's different because we've got different environmental impacts. So our time to repair matrix reflects the fact that we've got high H2S levels on some sites, and those assets that are exposed to that have a more frequent inspection program. We didn't understand fully the importance of the inspections and calibration, especially around PVRVs, and now we're running a program of inspections and calibrations to ensure that our gas system, our process, is containing the hazard, and the PVRV venting is an anomaly rather than business as usual. Process safety understanding of critical equipment. So certain bits of equipment within the gas process is critical, it's safety critical, and we've identified these bits of kit and they're flagged up now in our work management system. One of the issues we've had across all the sites is the operability of some of the equipment as it was designed. So we didn't embed process safety engineering into designs on our biogas sites, and that's created a bit of a challenge when it comes to the operability and maintainability of some of our assets. So we're in a position now where we've identified where these shortfalls are in design, and we're addressing that by retrospectively going through the HAZOP labour process to ensure that the gas process system has got appropriate level of design and equipment in it. The gap analysis has been carried out on all 5 of our biogas sites using the process safety approach, and that's completed now. So we've got a register of work that we're going to be doing. It's led to us taking the bold decision to take 3 of these sites offline and manage the sludge throughput until we can get some investment within the AMP. So we've identified our bioresource sites for IED work and for some remediation work from the gap analysis. So we've taken Trowbridge offline, Ham offline, and Berry Hill's coming offline this year, and that's going to enable us then to remove some of the assets that we need to replace and ensure that the design is robust and it's fit for purpose. Human factors. So we've integrated human factors in everything we do now. We're understanding that there's a impact of what people do and how they manage their workload and their safety critical tasks, how it impacts permitting and isolations. So we've got a design standard DS102, which is an inherent safer design, which should enable any design to understand about human factors and the impact of human factors, and design out where possible any potential human factors that can be an anomaly when that site or assets in operation. We've established a hierarchy of competency within our high hazard facilities, developed a training matrix, and we've now got a reference to our mechanical safety rules and DSEAR. So we're mapping across skill sets for isolation and process isolation under our DSEAR hierarchy. So we've got an SAP for DSEAR, we've got appointed people, we've got competent people, and then we've got the EX1s, which are our complex staff, which do their complex training, and then they go off and do a portfolio of work and experience before we sign them off as competent to go out and do inspections and remediation work on their own. Embedded into what we do on all of our high hazard sites is we've got an A2EX, which is a senior or an appointed person with training and competency to be able to manage contractors and ensure that all of the complex training within that site is up to date, all the internal training requirements are done, and all of the safety assessments are done prior to doing any work within that process. And management of contractors is really critical. We've got a new detailed process to manage contractors. So each contractor is assessed on their competencies to be doing the discipline that they're doing on our site. So if it's ATEX electrical inspections and remediation, or non-electrical, if it's process design, process engineering. So we've got a really robust process in place now to manage our contractors' competency. Formal assessment and authorization process. So within our work management system, raising of orders. So no orders can go out to a contractor that's not on the Bravo framework and signed off and formally authorized for that discipline. So there's a automatic barrier to orders going out now. You can't raise an order for anybody that's not been assessed and deemed competent to do that task. We've updated our process for review and approval of RAMs. Historically, the RAMs haven't been the best quality, and we've done a lot of work around understanding what we need in regards to risk assessment and method statements for work in the high hazard facilities, especially within zones, management of ignition sources, and a clear defined method statement for the task that's being undertaken on that asset on that day. So that's been a big step change for us. So all of our high hazard facilities are classed as requiring a permit for any work within a zone. So we've introduced a new permitting process, BioF 131, which is the overarching checklist. So when we do any work within a zone, especially if it's intrusive work, we have a electrical isolation certificate, mechanical isolation, process isolations. We have isolation schedule to support that. When all that paperwork, along with the RAMs and any other bespoke bits of paper that are required, that forms up the SSAW, the Safe System of Work. And once that's all been reviewed and approved, then an overarching permit gets issued to carry out that task. We've reviewed all our process diagrams and we've updated them. There's been a deviation between what was designed and what was as built on site. So we've done a gap analysis of that, and we're redoing a lot of our P&IDs. We're reviewing our process flow diagrams to understand from the very start of the process in our PSTs, our primary sludge tanks, right the way through the digestion process to the end product, how that process flow happens, what can impact it, and what we need to do to be able to manage it in regards to sampling at different points in the process. We've looked at our hack information. We've had to go back and apply first principles. A lot of the hacks were done by consultants, and we had a inconsistent approach to some of the zoning, and we didn't understand in detail why we had such large extents on some of our sites and small zones on other sites. And applying first principles and guidance and regulation now, we're reviewing all of our hazardous area classifications and updating just using first principles. As I said earlier, we introduced process safety right across the business to enable us to understand how we manage a hazard. So we've got a hazard inventory for waste and supply. That hazard inventory drives the requirements, whether or not we need to do a DSEAR risk assessment and then a hack. We've implemented across the business the hazard upload per QRA basis of safety approach. Safety critical equipment for ATEX equipment. So we've got all of our equipment on ATEX registers now. It enables us to understand what the type is, the inspection regime, and we've also implemented the non-electrical EXH type equipment, what those protection concepts are and how we keep them operable and safe in the working environments they're installed in. So there's a lot of work going on around non-electrical equipment, understanding the frequency, understanding the competency needed to do the inspections, thermal imaging cameras, recording daily, weekly, any trends of heat and vibration. So there's a lot of work going on currently, and it's going to continue to go on around the non-electrical equipment. There's been a lot of focus on permitting. Again, another way of looking at it is if you think you're doing it well and you think your permitting is good, get somebody outside of that bubble to have a look at it, because you don't really know what good looks like until you have a third party review it. You get almost used to doing what you're doing and you believe it's good, but it's really beneficial to benchmark against others or get a third party involved to look at how your permitting is operating and whether or not it's sufficient to manage the hazard appropriately. We've gone back to using industry best practice wherever we can, using the health and safety guidance, so HSG 253, in looking at the appropriate levels of isolation, the double block and bleed, where we should be proving isolations. We've done a lot of work, development and training around permitting, permit issuing, isolation schedules, pre-isolation checklist. It's all in our mechanical safety rules, and it's empowering people to use these documents to enable them to do the isolation safely and record what they're doing, why they're doing it, and how they're going to do it. So on the journey, Wessex Water are participating in industry-wide working. So we've got the Complex industry-wide working group now, which I believe pretty much all of water industry on, and we've also got some oil and gas and some API representatives at the Complex working group. We've got two process working groups. So we've got the Water UK Process Safety working group that Graham McEwen sits on for Wessex Water, and we've got the DSEAR working group, which Ian Spriggs chairs, and we have an input to. So this is a real positive change within the water industry. It's enabling as an industry to share best practice, share knowledge, share our incidents. We learn so much about some of the incidents we've been sharing to prevent incidents occurring in the future or repeat incidents. So the industry-wide working groups and platforms are really valuable for us to understand where we are. We can benchmark against each other. We can share information and documents. We can work towards having a common best practice within the industry to manage DSEAR, to manage some of the high hazard facilities that we're doing, to look at the best practices, elimination of the hazards where you can. So there's been a drive across the industry to reduce chlorine gas, and that's something that we're taking on board. Other hazardous substances like methanol, we're following industry best practice. So we're looking at removing methanol from our sites as a carbon source and looking at what the rest of the industry's been doing. We've had a really good uptake, and we've had some really good work done around the complex working group improvements to 9 and 10, looking at 11, and that's ongoing piece of work with John Harris. We're getting out and around to look at what others do, so visiting other utilities. We've been hosting visits to our sites and sharing some of the learning around managing our biogas and our high hazard facilities, and I hope that will continue long into the future. You learn a lot from going and look at what others do within the industry and outside the industry. So I'm hoping that's going to continue. We're doing a bit with postgrads, offering postgrad experience on high hazard facilities to come and look at the engineering, look at the way that we manage our high hazard sites, and give them the opportunity outside of the academic learning to really get some hands-on experience. And that's a wrap for me. So normally we'd ask for some questions now. So I think I've covered it all. So hopefully it's all good. Thank you very much for listening.